Okay, Chem students. So we're going to be practicing calculating specific heat today, or even finding some of the other variables that are in that equation. One thing you should know at the end of every chapter, they do list all of the formulas that we've gone over. So what I would do is keep an eye on these formulas, and as we go through them, mark them off that we've discussed them, so you should have them memorized by now. This might be a little bit longer of a video because the formula for specific heat and the word problems, they are a little bit more difficult. So you've really got to be orderly and work it out in a nice, orderly fashion and write the information down as you read it. So what I'm going to do on page 85, if you have your book, we're going to practice this one word problem in application number 1. It says, calculate the amount of heat needed to raise the temperature. So right now we know we're looking for heat, and we represent that by Q. So I'm going to put a question mark. Needed to raise the temperature of the water in a 40-gallon or 151 kilogram home water heater. Okay, so now we see we've got volume in 40 gallons or mass in 151 kilogram. So you kind of have to think, which one of those am I going to use in this calculation? If you know the formula for specific heat, it is C equals Q heat over mass in grams times the change in temperature. Okay, and that's going to be in degrees Celsius, because if you remember, specific heat is joules per grams times degrees Celsius. Okay, whatever value you have with that, those are the units. Okay, so we know that our heat needs to be in joules, our mass needs to be in grams, and our temperature needs to be in Celsius. Okay, so we are given 151 kilograms of water. Okay, so that's going to be our mass, but remember, we need it in grams. So 151 kilograms will convert to 151,000 grams, okay? Now we need our change in temperature. You're always going to start with the final minus the initial. Okay, so we're going from 19 degrees Celsius to 60 degrees Celsius. So 60 degrees is our final. And I'm going to keep all the digits that they give us so that at the end we can have the proper significant figures. Minus 19 degrees, because that is our initial. 19.0 degrees Celsius. Okay, so 60 minus 19, keeping sig figs, is 41.0 degrees Celsius. Okay, now we can plug everything in. Actually, we can't yet. You see we're missing something? I have Q, M, and delta T, but I don't have C. But you can find it, okay, because we are given specific heat of selected substances right in this table. Okay, so we've got water is 4.18, and remember that's joules per grams times degrees Celsius, okay? So 4.18, C equals 4.18 joules per grams times degrees Celsius, okay? All right, so now we can plug everything in. But again, we're looking for Q. So I'm gonna solve this formula. I'm gonna erase this for now. I'm gonna solve this formula for Q. So I'm just gonna multiply both sides times M delta T, okay? M delta T. So these cancel out, and I'm left with Q equals M times delta T, put a little time symbol, times specific heat, okay? Don't get confused that C does not stand for degrees Celsius. That stands for specific heat. Now we can plug everything in. So Q equals our mass of 151,000 grams times our change in temperature is 41 degrees Celsius times our specific heat, which is 4.18 joules, all over grams times degrees Celsius. So my degrees cancel out, my grams cancel out, and then once you do the math, so we're going to get 151,000 times 41 times 4.18 equals, it is a large number, it's 25,878,380. Okay, that's the exact answer, joules. And to keep with sig figs, we are going to stick with, okay, we've got 3, 3, 3. So we need 3 sig figs, okay? So it's going to be 25,900,000 joules. And that's your final answer, okay? Now I am going to do the next problem because I know these are tough. So, okay. So looking at application number 2, we're going to move on to this next problem on page 85 if you have it. Okay, how much heat is needed? Okay, so right there you already know, what are we looking for? We're looking for heat. And how is that represented? It's represented by Q. So I'm going to do Q equals question mark. To raise the temperature of 1 pound or 454 grams, there we go, we've got our grams, which is our mass, 454 grams of aluminum from 25 degrees Celsius to its melting point, 660 degrees Celsius. Okay, so that's our change in temperature. So our final would be 660. And they do include a period for sig figs, minus our initial of 25.0 degrees Celsius. So that equals 635 degrees Celsius, okay? And it tells us also that the specific heat of aluminum is 0.900 joules per grams times degrees Celsius, okay? So now we can plug everything in. If you remember before, we got Q equals, and these are all multiplied together, delta T, specific heat, okay. So plug everything in, 454 grams. And I would suggest leaving the units in when you plug everything in to make sure that you're doing it all correctly and everything cancels out as it should. Times our change in temperature is 635 degrees Celsius, which is positive because we're ending at a higher temperature, so it will be positive. I'm sorry, we're not ending at a higher temperature. We actually went down a little bit. From 660 to 635, I apologize. Okay, and then times 0.900 joules per grams times degrees Celsius. So degrees Celsius cancel out, gram cancels out. And you do the math, 454 times 635 times 0.9 equals, okay, so it is 259,000. 461, and sig figs, we have got 3, 3, and 4, so we're going to use 3 sig figs. So it'll be 259,000 joules, about, and it can also be 259 kilojoules, okay? All right, and so just make sure you memorize those formulas. And when you're doing the word problems, just start with laying everything out. Once you see all your information laid out, if you're doing your job of memorizing these formulas, you'll be able to go, I know which formula to use. Now let's just set it up. Okay? Good luck.